Next topic, secure configuration and identity. So secrets are stored in Azure Key Vault. AKS users manage identity, no secrets code in code, OA or OAML, that means our CI/CD pipeline. So why? Because we need zero secret leakage, central secret rotation, we need to update it regularly, and enterprise security level we need. So outcome will be secure microservice and service to service communication. So we have synchronous communication, order service calls product service, and protected by JWT, retry, and circuit breaker pattern. For asynchronous communication, we use Azure Service Bus. So order service publish event using Azure Service Bus, and notification service consume it. So why? Because async equal to resilience, no tight coupling, and better scalability. So Azure Service Bus, what is it? Azure Service Bus is a fully managed message broker used for reliable asynchronous communication between services, and think of it like a durable message queue in the cloud. So why we use it? So decouple the microservices, handle traffic spikes, ensure no message loss, and reliable communication between services. So core components like queue, like one-to-one communication, one procedure, one consumer, and message processed only once. Example, order service to payment service, and topic and subscription. So one to many. So one producer, multiple subscribers. So each subscriber get a copy. So like order service create event, email service, inventory service, notification service, everything will get. So key features: reliability, message stored until processed, no message loss, and retry and dead letter queue. If message fails multiple times, moved to DL queue. Helps debugging and reproducing. And scheduled messages, send messages to the processed it later. And duplicate detection, so prevents processing same message twice. And message sessions, guarantee order processing. Security, Azure AD managed identity, so no connection strings in the code. Service bus vs RabbitMQ vs Event Grid. So these are RabbitMQ and Event Grid also kind of a messaging queue service. So the differences between the features: so guaranteed delivery, it is guaranteed in both, but Event Grid not. Messaging order, here we have, and long processing we have advantage. And even fan out, Event Grid wins. Enterprise ready we have in service bus. And database isolation, then database isolation. So each service owns its own database, uses its own connection string, no cross-service DB access. Why? Because no shared schema risk, independent evaluation, and failure isolation. So outcome, true microservice, not distributed monolithic. And then observability and tracing. So every request gets a correlation ID, logs, traces, and dependencies flow into application insights. We can see end-to-end request path, failures, latency. So why? Because debugging in distributed system is helping, and faster incident resolution. So outcome, full visibility. So observability and distributed tracing, how we will use this and how to implement. So the goal, track one request across multiple microservices, know where it failed, why, and how long for each step took. So we implement correlation ID, generate a correlation ID at the entry point, pass it to all downstream services. So using the API gateway or ingress. So read the trace parent or generate one if missing, and store it in HTTP headers, logs, and application within content. And the next, failure handling and resilience. So what happens if product service fails, order service retries, and circuit breaker opens, fallback is used, and system degrades gracefully. So why? Because failures are normal. System should survive the partial outage. So we have to handle these all and production ready resilience. The goal is to system should not crash. Failures are expected in distributed system. So application must degrade gracefully. So suddenly in middle one service might down slow or returning errors. So what we have to do? We have to add a retry for few minutes, and if it's still failing, we have to open circuit breaker and use fallback responses and keep system running. Core resilience pattern used here. So retry, so purpose is handled temporary failure, network glitches, timeouts, and the rule will be like retry only safe operations. And the circuit breaker, stop calling a failing service and prevent cascading failures. States will be like closed normal, open fail fast, and half open test recovery. And then timeout, the purpose is don't wait forever, release threads quickly. And then fallback, return default cached partial responses, system stays usable. Bulkhead, isolate failures, one service cannot consume all the resources. So how we implement this? Step 1, use resilience library. In .NET Poly is a standard library. Why? Because we have a retry, circuit breaker, timeout, fallback, all the industry standards we have. And then step 2, we have to configure the HTTP client with resilience policies. Step 3, retry implementation. Step 4, circuit breaker implementation. Open for 3 failures, stay open for 30 seconds, move to half open after effect, order service stops calling product service, immediate failure response. And then fallback strategy. So return cached product list, return product info unavailable, allow orders without price confirmation. So business decides fallback behaviors. And then add the timeouts. So always set timeouts lower than load balancer timeout, gateway timeout, and example timeout will be like 2 seconds. Step 7, observe failure. So integrate with application insights, logs, metrics, track retry count, circuit breaker, open events, fallback usage. Now the next topic, scaling only hot services. So what happens here? HPA monitors the CPU load, only busy services scale, order service scales more, and notification service scales less. So why we have to do this? Because for the cost optimization and performance where needed. So the outcome will be effective auto scaling. What we are doing here, each microservice runs in own deployment, has its own auto scaling rule. So order service scales up during the high traffic, notification service stays minimum replicas, independent scaling per service. So and then tools used and why. Tools AKS, Kubernetes container orchestration, and has PA, horizontal pod autoscaler. So it auto scales the pod based on the load. And metrics server providers CPU metrics and application insights, observe traffic and latency. Azure monitor promoters, custom metrics, and Docker package.NET service, canary and safe release. So what happens? We have a new version deployment, but it should not go wrong. So we have to save this. So new code can break the code even if the tested passed, even if UAT was green. So releasing to 100% yours at once, it's a kind of risk. So canary release means release safely to a small audience first. So what is canary release? So like miners sending a canary bird first. If bird survives, mine is safe. If bird dies, stop immediately. In software, small percentage of users get new versions. Majority stays on a old stable version. So real time flow here, like step 1, existing stable version we have, and deploy new versions as a canary, like just 1 or 2 ports only, same service name, same API. So product service version 1 will have 90% traffic, and the product service v2 have 10% traffic. If you see this first step, product service 1 v1, so runs in 10 ports and the traffic is 100%. Now we are deploying v2 to just 1 or 2 ports, same service name, same API. So 1 or 2 ports means just a 10%. So this can be done using AKS plus Ingress or Azure application gateway or service mesh. Route small traffic to v2, Ingress routing example. So 90% of v1 and 10% to v2. Only few real users hit v2. So this is real production traffic, not test data. What metrics are compared? We continuously monitor error rate and detect crashes and response time, performance regression, and CPU matters. It matters because resource leaks and dependency failure for downstream impact, and business metrics for orders placed and payments. So these tools we will use like Azure Application Insights, Log Analytics, Prometheus, and plus Grafana, like those things we can use. And the next, security hardening. What happens? WAF blocks SQL injection, XSS, rate limited applied, DDoS protection enabled. So why? Because internet facing service must be protected. Outcome, enterprise grade security. Security hardening. So what problems we are solving? So our microservices publicly accessible, exposed to internet, constantly attacked by bots, scanners and hackers. So security is not optional here. Every public API targeted from day one. So where security hardening happens? So internet we have WAF layer 7 protection and application gateway ingress, AKS services and .NET API and to databases. So never trust external traffic. So web application firewall. So that is what WAF. A gatekeeper that inspects every HTTP request before it reaches to your API. So what WAF blocks automatically? So SQL injection. So attacks like products ID 1 or 1 equal to 1, something like SQL injection. So WAF, I will repeat, web application firewall. It detects the SQL keywords, malicious patterns, request blocked before reaching the product service. And cross-site scripting, attack can happen something like this. So this script injection, the malicious payloads, it will block that. And the known explorer like OWASP top guidelines, command injection, path traversal, deserialization attacks, like those things. Azure uses OWASP core rules it. And rate limiting. So what problem can happen? One client can spam request, exhaust ports, cause denial of service. How rate limiting works? Like 100 requests per minute per IP. They can loop it if it exists HTTP 429, too many request will be blocked. And where this will be applied? Azure WAF application gateway ingress control. controller. And DDoS, what is it? So thousands or millions of requests hitting your application from bots, from compromised machines. So the goal is take your service down, and Azure DDoS protection automatically detects the abnormal traffic, observes large traffic spikes, drops the malicious packets, so no manual action will be required. I will repeat. So what is DDoS? So millions of requests hitting our application from bots or compromised machines, and the goal take your service down. So Azure DDoS protection managed, it will do automatically detects the abnormal request and observes the large traffic spikes and drops that to malicious packets. No manual action required. Secure access to APIs. So authentication, we can use OAuth, JWT, Azure AD, and API gateway validators token. And if no token, request rejected. Authorization, role-based access, scope-based API, least privilege, like those things. And network security, often missed, private networking, databases in private subnet, and no public IPs. Only AKS can access it. And then runtime security in AKS, port security, no non-root containers, read-only file system, and minimal base images. And then monitor and alert, this is very important. So security signals from WAF, blocked request, high 401, sudden traffic spikes. So for those things we can trigger alerts, email, pager duty, and Teams.